Good morning. Welcome to this session. I'm Prasad. I'm co-founder and CTO of Okahu. I've been working in the data space for a while and now in AI for the last few years. Hoc, would you?
Yes, my name is Hoc Phan, and I work with Prasad. I'm the lead of developer experience.
Cool. So in this session, we're going to talk about the AI agents, how to find and fix issues. So let's get started. So agents have become a big phenomenon in the last couple of years. It's a very powerful primitive. It basically allows you, instead of coding static workflows, it allows you to harness the power of LLM and to dynamically navigate in your workflow based on what user is asking. Your agent is essentially a collection of prompts. You decide what you want to do. You leverage the context, like the history of the conversation that's happening, the additional context that you can pull from the other data sets. And then you have a set of tools to perform the actions based on that user's ask. And then you go to LLM and says, this is what I'm supposed to do. These are the things I have that I can do. And this is what the user is asking me to do. So what should I do? So you get into that think and act loop. The LLM tells you to either say execute a tool. So you call that tool, get the answer back, and ask the LLM again, and keep in that loop until the LLM says either the job is done or you cannot proceed anymore, and you get that answer back to the user who's asking you. So this makes you build these dynamic workflows, and it makes it a very powerful solution that people are leveraging very heavily. Now, on the other hand, the use of LLM, the non-deterministic nature of this dynamic workflow, make things pretty complex and very brittle. So managing these agents, finding the problems, and fixing them is a real big challenge for people to take these agents in their prototype from their laptop to their production. So what's my ideal solution, right? Let's say I'm using my coding agents, like Claude or GitHub Copilot, et cetera, to help me build the code. What I want is a way to analyze my agent. Want to see what that agent doing under the cover. I might be using popular agentic frameworks like LangChain, Llama Index, or Google ADK. I want to get a picture of what's happening when I submit a question to the agent and I get the answer back. I want to see that logical picture so I can debug. And the knobs that I have, I can change the description of my agent. I can add or change my tools. Or I can choose what model I want to use. So I want to get an insight into how that agent is behaving. Two, I want to be able to test it at scale. I have my golden data sets. Like I know when I ask a certain question, what that agent should behave, what tool it should call. So based on that, I want to be able to create a lot of test cases that I can validate my new functionality, as well as continue to make this as my regression test as I updating my agent. And then once I deploy this, I want to continue to monitor that agent, all that insights for everything I'm doing on my laptop. I want to continuously capture that when the agent is running in my real production. And then to find the problem at scale, I want to be able to evaluate them, which basically means I bring another LLM as a judge and evaluate that behavior and see, is the user sentiment negative? Well, if it's negative in 5% cases, go double-click and say, is that because it's off topic? Somebody's asking a question that's not relevant. So, well, there's nothing I can do. But is it still on topic, but my answer is not relevant, so maybe my agent is hallucinating? And those are the problem ones. Then you want to bring them back into your development environment and look at that insights, like what's happening. Feed that into your coding agent, says, this is what I asked to do. This is what should have happened. But this is my trace. This is what happened actually. So help me find the root cause of that problem. Fix it. Rerun my regression test, which I built, and make sure I'm not breaking my existing behavior, and deploy it and continue in that loop. So that's how I would like to monitor and debug and fix problems. So what tools I have? So that's where Project Monocle comes in. This is a Linux Foundation AI and data project. It helps you generate a logical view of your agentic operation. It's a very simple thing. The Monocle community has already done the hard work of understanding the underlying frameworks, how they behave. So you just call a single API, and it paints the picture of what your agent was doing. In this case, my agent turn started. I asked a question. Some agent got invoked. That delegated to another agent. It called an LLM. LLM says, make a tool call. It called a tool, et cetera. So it gives me that logical picture of what's happening. It's not tracing my underlying third-party library code, but it's telling me how my agent is behaving, so I can choose to fix my tool or my prompts, et cetera. So this is a visualization of that trace in detail. There's a Visual Studio extension that you can download directly from the marketplace, also for Cursor or Anti-Gravity or Kiro, whichever Visual Studio equivalent IDs that you're using. And it helps you to visualize this trace, look at the details of what's happening at every operation, what question was asked, what answer was given for the LLM, how many tokens I used, et cetera. So this becomes a powerful tool for you to debug your agent behavior in your development environment. And then you can interact this with your coding agent. You can give this trace to your coding agent and say, help me find the problem or help me understand the behavior. This is my code. This is what happened when I ran a certain thing. Help me analyze and find the issues there. And then Monocle also provides you a framework to do the agent testing using the same trace that it generated. So here I ran a test, said, give a prompt to my agent that says, book hotel. And then I assert against that agent's behavior, that when I'm doing a hotel request, I know it should have called the hotel tool. It should have a reservation number in my response. I also want to make sure this interaction is less than, took less than 5,000 tokens, took less than 300 seconds, et cetera. And then I can also run evaluations on that. In this case, I'm using the Okahu eval engine. You can bring in, of course, your custom engines and extend it to hook it in. So as a part of my test, I check for the deterministic behavior and also use LLM as a judge to test the non-deterministic behavior. So this becomes my gate for me to take that agent from my dev to deploy in the prod. And once this is deployed, I can continue to monitor it. So this is a Okahu solution, that same trace the Monocle generated. You can view it in the Okahu cloud. It shows you the graph of what that agent did, like what steps it took. And then you can analyze it further. This is the observability agent. You can ask questions that, what happened in this particular trace, help me evaluate it and tell me, whether this is off topic, the sentiment is right, whether the agent might have hallucinated. And you get a lot of this summary from your observability agent that you can decide then whether this particular case needs to be, further analyzed, trying to find that needle in the haystack. And take that summary and then pass it down to your coding agent. So this is, you can pull that summary either locally or from your cloud store back into your development environment and analyze it yourself, or you can use your coding agent to help you analyze that and help find the root cause of the problem so you can fix it and deploy it. So that's my cycle. As I said, I use my coding agent to help me build my code or fix my code. I run my test. I deploy it. I continue to observe it, and I run other evals, bringing another LLM as a judge to find that needle in the haystack. And once I find those problem cases, I bring them back into my development environment and continue to iterate on it. So let me just show a couple of quick examples. So this is my example agent. It's a agent that talked to NBS database and asked questions about what happened in the game. So it's like it says what happened in the Thunders game yesterday, and I got the score. The NBA data is public. There's even a Python library that you can use to query that. It's just that they block all the clouds, so you can only run it from the non-cloud database. Non-cloud hosted. So this is an agent that giving me answers about NBA game score, and I have instrumented that with Monocle just by adding this. And then I see, what happened in that that agent's execution. That when I asked a question, it invoked an agent that talked to an LLM. An LLM said, call this tool. I have this tool called get scores, and it called that score, which under the cover called the NBA REST API, got the answer back. Then I went back to LLM, what to do next, and LLM said, OK, your job is done, and return the answer back to the end user. So you get this picture by just adding this one single line of code. And this is compatible with a number of agentic frameworks and inference SDKs. Like in this case, I'm using AWS Strands. And this is an example of that test case. So I'm just, that same NBA question, I'm trying to verify that when I ask a score, I get the right tool that I'm invoking. It should contain the right output. Like when I'm asking a question about Lakers, it should say about Lakers. I'm verifying like how many tokens I should use. It shouldn't use more than 1,000 tokens. And then I'm also doing a sentiment evaluation using the Okahu engine to see what was the sentiment. So please check it out. The project is, as I said, it's open source under Linux Foundation. Please give us a star on the GitHub. Join our Discord channel, ask questions. We'll be happy to help out. Let me hand it over to Hoc to walk through a more detailed use case. Yeah.
Okay, thank you, Prasad. So I'm going to talk about one scenario that I heard a lot from people that I talked to. Basically, how to deal with agents in CI/CD. So I have a scenario here that we have an agent. Let me turn on this color here. We have a travel agent. And the travel agents basically do a flight bookings or the hotel booking. And in CI/CD, you see a lot of cases where things failing and you don't know what happened or why it fails or how to actually fix it. So the scenario here is that I have a travel agent that I'm going to invoke it in the pipeline, and this is actually sit inside the GitHub. What Okahu provides two things. We have a framework that can actually call a prompt and execute through a particular test. And when the test finishes, we invoke our Okahu agent that actually look into the traces. So Prasad just walked through, how you capture the trace and how you instrument with Monaco. We capture all this information and we summarize the information and we kind of generate the context for Claude or Copilot or Codex to go ahead and fix the code. So the scenario here is I'm going to say I book a flight from one place to another next week. So the keyword is next week. Next week is a very general term. If you call Orbitz or Expedia, you tell them book me a flight next week, they're not going to know what exact date. So this test going to fail, right? And there's several requirements that I'm looking at. So there's a trace asserter platform. This is from Monaco itself. And basically, I want to know that the book flight tool not supposed to be called, right? But the hotel one should be called, and when you run the eval, there should be no hallucination. So that that's the artificial scenario. The test will fail. So the test run through, it failed. It's expected because the prompt is injecting a phrase that will make it fail. The next step is that it create a GitHub issue. So this is what we provide in the workflow inside the GitHub. When the test fail inside the Monaco, we capture the information and create a GitHub issue and invoke the Okahu agents to investigate on the issue. So what you see is that the GitHub action will generate this particular tickets or issue with all the detailed information that you see here below. And it would tag the Okahu agents here. And it's going to take a couple of minutes or so to go back into the system and get the trace information and analyze it. The key thing is that you have the analysis already done. One, the agent already in production, let's say. It's invoked and the agent run through the prompt, and it will tell you why it failed particularly. So it explains step by step and provides some of the conclusion. At this point, it doesn't fix anything. It's basically acting as an L1 support, kind of agent. And the next step in the flow is to assign to Claude. So Claude or Copilot or Codex. So this is the native feature inside the GitHub. Once Claude pick it up, it has all the context already. It starts to create a pull request. So again, this basically the native feature of the GitHub, but the cool part is that Claude already have a context from the Okahu agents. So it analyzes the context and it creates sections, right? And it starts to go to the step and fix everything, starting with the test requirements. So what's interesting here is that you don't tell Claude to hey, fix the problem. You tell Claude to make sure these 5 things are fixed, If it doesn't fix, go back and do evaluation again. So this whole thing runs as a loop. And once the loop only completed when the 5 tests that I showed earlier are complete. So if this one still failed, then it keep going until the whole thing is fixed. And for this basic example, it's very simple. It's just a prompt change in the code. After the prompt change, it verify and give you the conclusion that everything is fixed. So the claw part is, not this, basically a part of GitHub. But the interesting thing is that the Okahu agent provide all the context and the test. So think of the test as a way to deterministically say that I want to make sure the 5 tests are done and always success. Otherwise, go ahead and go back and try to figure out what's wrong with it. Okay, so back to you, Prasad.
Cool. Thanks, Hoc. Yeah, I think we are almost at time. So yeah, that's basically what we wanted to talk about, how do you, a mechanism that Monocle introduces with help of Okahu to find and fix problems in your agent code. That's a great use case that Hoc demonstrated. So that's basically all we had. Thank you very much.